Okay, so we're again tasked with finding the function of the derivative and the value of the derivative at a point. So what we're going to do is we're going to once again recall the limit of the difference quotient. And so what I'm going to say is that it is f of x, the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And this one's an interesting problem because it's got this kind of rational, it is a rational function rather, 8 over x. And so it's actually kind of neat the way that it works out. You just have to really like, adding fractions. If you could figure that out, then this is no problem finding this derivative f prime of x. Okay, so let's see here. Let me write it out. The limit as h approaches 0 of 8 over x plus h minus 8 over x all divided by h. All right. So what we're going to do is we're going to subtract fractions in this case. So in order to subtract or add fractions, you need a common denominator. The denominator here is going to be the product of the two denominators that's present, the x plus h and the x. So I'm just going to multiply this by x in the numerator and denominator because I can only multiply by 1. And x divided by x is 1. And this guy over here, I'm going to multiply him by x plus h and x plus h. So it's going to look something like this. Okay? So I'm going to multiply by that. And then, of course, I'm going to do some distribution, combining of like terms and all that good stuff. So that's next on my list of things to do here. The limit as h approaches 0, I'm going to have 8x minus 8x minus 8h. That's not too bad. All divided by x times x plus h. Okay. All of that divided by h. So it looks kind of weird, looks kind of wonky maybe, but that's okay. All right. Looks something like this. And what I'm going to do is I am going to write this out. If you notice, we're dividing by h. So what I'm going to do is I'm going to write that out as being multiplied by 1 over h. And I think that'll make this a lot nicer. So let's see. The limit as h approaches 0. I'm going to have a negative 8h on the top. I'm going to divide it by this x times x plus h. That's okay. Now the divide by h, this part in yellow, I'm going to multiply it really by its reciprocal, 1 over h. Now why did I do that? Because I tell my students, whenever you're dividing fractions, always remember 2 KFC. Now I'm not talking about your favorite chicken joint. All right, what I'm talking about is when you're dividing fractions, always remember, keep the first fraction, flip the second fraction, and change the sign from division to multiplication. So that's what I've done. The divide by h becomes times 1 over h, the flip of h. All right, keep, flip, change. All right, so then as you see, we have this h that we can now cross out. We can cancel it out, cross it out through division, whatever you want to call it. It's really not cancel. Cancel means you're left with 0. H divided by h is 1. So anyway, the limit as h approaches 0, you do that little trick there. You get negative 8 over x times x plus h. And now we can legally plug in h is 0. And it's not a big deal. That goes to 0. You're left in the denominator with x times x. So you're left with negative 8 over x squared. All right, so that's actually really neat because this is actually the derivative f prime of x. And I'm going to tell you at some point a little bit later, you're going to get so good that you're going to be able to look at this f of x as 8 over x, and you're going to be able to tell that it is this right here, negative 8 over x squared. You're going to be able to do it really quickly in your head. But right now, we're learning how to crawl before we can walk and then eventually run. All right, so that's what's coming. So brace yourselves. So anyway, let's take a look at this right here, f prime of x, and we're going to say, well, what's f prime of 1? Or actually, what did they ask for? Negative 1. F prime of negative 1. That's what we're looking for. Okay? So that's simple enough. You plug in negative 1 down here in the denominator. You square it. you're left with negative 8. So this is f prime of negative 1. Looks just like that. Looks just like that. Okay, so nothing to it. We have the function of the derivative here, and we have the derivative evaluated at negative 1. Interesting. All right, let's go ahead and take a look at one more example. Okay, now in this problem, it looks a little bit weird because you see that it says ds over dt. We read it ds dt, and it says such that t equals 2. So it says find ds dt such that t equals 2. What in the world does that mean? What they're asking us, if we have this function s, they're asking us to find s prime of t, the derivative. All right, and then they're asking us to find s prime of t, or I'm sorry, s prime of 2. So they want us to plug in 2 into the function of the derivative. But what in the world is this? Well, this right here is what we call the Leibniz notation for a derivative. All right, so ds dt is the same as saying s prime of t. All right, they are the same thing. It's just one guy named Leibniz came up with this stuff here. All right, and that's where it got its name from. Okay, Leibniz and Newton were around the same time period, you know, late 1600s, early 1700s, and there's actually a big debate amongst them about which one of them actually developed calculus first. And so it's quite interesting. Interesting guy. He was a German, I believe. And there was a lot of stuff going on, but this guy was kind of like a Renaissance man. They call him a polymath. He just knew a lot about a lot. Okay, so what they're asking us here, in essence, the question, if you will, is what is the derivative of s at t equals 2? Okay? Okay. So what we're going to do is we're going to find the derivative. All right? Now, oh, by the way, just an interesting fun fact. You can probably look this up on Amazon, I think, because I know nowhere anywhere where I live they don't have these, but there's these Leibniz. I don't know if they're Leibniz cookies, Leibniz biscuits. It's a cookie, but I didn't even know they existed. I was taking a math class at Harvard, not to name drop or anything, but I was taking a class and the professor was offering a prize for whoever could answer the question, and it was an advanced calculus question, but the knowledge that was required to answer the question was not even calculus. It was a trigonometric identity. It was like a cosine squared plus sine squared equals 1 kind of deal. And I was the only one in the class that apparently knew it. I said the answer and I won the prize, which were these Leibniz cookies or Leibniz biscuits. I don't remember, but surely you can find them online somewhere. Rather interesting little cookie. But anyways, I digress. I went off on a tangent. No calculus pun there intended. But let's find s prime of t. All right. S prime of t. Let's see here, which is ds dt. Let's first find the function. All right, so this is the limit as h approaches 0 of s of t plus h minus s of t, all divided by h. We're going to do that. We're going to find the limit as h approaches 0 of, let's see, t plus h square minus t plus h minus, and then I'm going to put the original function s, which is t squared minus t, all divided by h. Okay, so I have the limit as h approaches 0, and I'm going to do the quick binomial expansion. T squared plus 2ht plus h squared, looks something like that. do the distribution here and the distribution here. Can't forget that. I know I forgot that in one of the videos and I had to go back and fix it. Minus t minus h minus t squared plus t, all divided by h. I combine my like terms. Let's see what cancels and what doesn't. The t squares cancel, the t's cancel, and I think that's about it. Now what I'm going to do is I'm going to divide the h. So let's see what I get. I get the limit as h approaches 0 of 2ht. Well, let me just rewrite it and then I'll divide. Looks something like that. All divided by h. There we go. The limit as h approaches 0 of 2t plus h minus 1. And I know that h goes to 0. So what does that leave me with? 2t minus 1. This right here is my s prime of t. It is my ds dt. Same thing. They're synonymous. Okay. Now I'm going to find ds dt such that t equals 2. What does that mean? That means plug in 2. It's nothing major. Okay. So what does this equal? 4 minus 1, which is 3. And so this right here is my ds dt such that t equals 2. All right. Nothing to it. Really nothing to it. Leibniz notation. Really neat stuff. Maybe you'll want to learn more about Leibniz. I don't know. But really nice problem here anyway. So hopefully this video was helpful as always. And remember, like and subscribe.